Streetlight's construction solution lets you ensure that project decisions are informed by validated data-driven insights by expediting construction, improving work zone safety, planning better detours, reducing driver frustration, and improving team communications. With Streetlight Construction Solutions, you can pinpoint and mitigate traffic disruptions in construction zones. Before the build, view traffic patterns to optimize closure allowances and create data-driven detour plans. During construction, observe traffic flows, even in real time, to dynamically adjust plans and build targeted public messaging about disruptions. Post-project, analyze travel patterns and generate reports to illustrate the improvements.
Here we see a map showing typical expected traffic volumes just before the ramp was closed and the detour activated. The planned detour route intended to bring motorists from I-90 eastbound down I-95 south, past this Grove Street exit here, down to the Route 16 exit where they could double back on the ramps there to set up for I-95 northbound. So that's what should have happened. Just 15 minutes later at 11:30 p.m., we'll see when the ramp closure began. And I have the map zoomed in on the ramp that was closed, and we can clearly see it shown here in blue, which in our color scheme is indicating much lower than typical volumes for this time of day, which we would expect. Volume is 0 because of the closure. Now, as an aside, let me also point out a detail we can see now, since this is a historical example showing a situation some months ago. We can see not only the old ramp configuration that was present at the time of this closure, that's a segment colored with our volume metrics, but also we can see our base map, which is separate from the data, has already been updated to reflect the new ramp reconfiguration that's present today. This looks a little funny, but is actually illustrating a key feature of construction solutions, that we're frequently updating the road network we use in the tool as well. Which makes sense, given we're focused on roadways under construction with this tool. Sometimes the locations and configuration of the network is going to change a little bit, and we want to make sure that we're capturing that and saving it, like in this case, when viewing older points in time. Just 15 more minutes later at 11:45 p.m., the detour should be fully underway. But back in this zoomed out view, we can start to see what went wrong. The Grove Street exit ramp and on-ramp that redirected vehicles right back into the closure work zone is clearly highlighted in red here, indicating much higher than normal volumes of traffic taking this incorrect route. As we look to the Route 16 ramp further south, it's saying in that yellow color, indicating more typical volumes, when it likely should be showing in red itself to account for the increased non-local detour traffic. Using Construction Solutions timeline views ability to step through time like we just did and view the whole network, not only could we see the location and timing of the onset of the issue, we can see when the issue was resolved later in the day, as well as all the key locations involved. And I think that's an important point. When these vehicles were finding their way into the work zone, the crew on the ground at the time didn't necessarily have this higher level big picture view to understand where things went wrong. And understanding exactly why and where those things happened is critical for us to avoid repeating a similar mistake later on in the project. Now to actually get into the Construction Solutions tool, where I'll show some live examples. I'll start first with one of our projects in the Metro Atlanta area. We've been working with another Jacobs team on behalf of GDOT on the I-285 pavement replacement project in Atlanta. That team needed traffic volume metrics in order to plan when to do lane closures to start their paving work. So we'll start here in the Construction Solution Tools Volumes tab, which is a key area of the tool used in planning lane closure times. I have the map zoomed in here to the I-285 and I-20 interchange area. And our first step here is to select a road segment that we want to analyze. Then I can open the chart volumes for that road. The chart shows volumes in 15-minute intervals for a typical weekday, Saturday, and Sunday in July of 2023, as shown by that yellow line I was just hovering over, as well as the roadway capacity in vehicles per hour shown by this green line. And the green line is determined by the lane capacity that I can set here, as well as the number of lanes that I plan to have open during the construction period. And as you can see As I adjust that capacity and the number of lanes that we have open, the yellow highlight bands on the chart change to highlight the period when the volume typically falls below capacity. So this shows the times of day when I'm least likely to cause congestion by implementing this lane closure. For a summertime closure in July, we'll need to reopen the lanes at about 5:15 in the morning, and I can close them starting about 9 p.m. on Friday evening. Now, with seasonal variations in traffic, there may be opportunities for wider construction windows depending on the time of year. So by simply going over here and changing the reference month, in this case, I'll move from July to February, I can see that the evening volumes are slightly lower, and I can close the lane as early as 7:45 p.m. that evening. So hopefully you can see now how this simple tool and view can be used to plan more precise and efficient lane closures. And the ability to provide a contractor with additional hours to do work without causing massive traffic backups can help improve the efficiency of the project and speed up completion. I have a second example. So GDOT is actually planning to close the SR 42 North Druid Hills Road Bridge over the Peachtree Creek for the next few months to reconstruct it. And in preparation of that, they were conducting a pacing operation. We can quickly see that event on the Construction Solution Tools Speeds tab. And I selected the segment. I have the 15th selected from our date picker. And then when I open the chart, I can see the 11 p.m. period highlighted in the chart here, where there was a quick dip in speeds from 35 miles an hour to 19 miles an hour, indication of the pacing. So this chart is showing me the specific date speeds in yellow and comparing that to the comparison month of March 2024 in blue. And the free flow speed of the road is also given in green as a reference point. So in this case, the pacing operation seems to have gone well and traffic recovered quickly, but it just as easily could not have in another scenario. And perhaps we have gotten some complaints from the public about being stuck in traffic that we'd want to respond to. Construction Solutions is always on, collecting data across the GDOT District 7 area, available for the team to inspect and investigate issues that may come up, not only on the large interstates, but also on these smaller local arterial roads. I'll end with another event that we saw recently last month back in the Newton Weston project area. Rather than a planned construction activity, this was a vehicle crash that happened during the weekday rush hour on March 27th. Starting about 7:45 in the morning on the I-90 eastbound to I-95 southbound ramp. Once again, the speeds tab here highlights for us the times when the event happened and then how long it took for those traffic speeds to recover over the next few hours as emergency teams address the situation. But let me switch to the travel time tab, which allows me to define a more complex route of several segments through the whole ramp complex between the interstates. I can do this simply by clicking the first segment and then clicking the end of the route where I want to analyze. Here on this chart, we can see that the crash's total impact to traffic taking this ramp route, where the backup added about 10 minutes to travel times over this 45-minute period after the crash, as well as two other minor slowdowns that we saw in the speeds view before recovering back to normal at around 10:30 in the morning. We can also use the timeline view to see the speeds just before and after the crash across the whole network. If I switch to timeline now and I'm starting at 7:30, just the first kind of timed in where we're initially starting to see the first bit of backup on this ramp. And since this is the morning rush hour and likely to be congested anyway, even without the crash, the timeline view's atypical speeds option is also useful for highlighting specific areas that are not performing like we would expect them to be at this time of day. As I step through from 7:45 and into 8 and 8:15, the affected area, we can also see how the impact of that crash and backup on the ramp impacted overall speeds on the main line and how far that backup grew and when it finally dissipated by 8:45 as traffic begins to flow again. The timeline view enables you to analyze an emergent event that happened like this crash and how it fully affected the surrounding road network, as well as responding to any complaints by the DOT or the public following an incident like this.